Okay, assalamu alaikum. I'm going to do a physics um, a physics challenge, which in actual fact covers an enormous amount of basics knowledge of trigonometry, maths, geometry, algebra, and physics. So this is actually a physics problem. Okay, it comes up every time. Okay, and if one actually studies this, you have a very good understanding of how all the different things that you are taught comes into play. Now, where the Muslims have led the modern world is that Al-Harizmi created the trigonometrical tables, which is the sine, the cosine, etc., which is a relationship between sides and of a right angle triangle. And these are constants, in nature. So he basically developed that, wrote up a table, and then that is now in the computer that we've got here. Now this is very, very, very important for computers, for everything that you want to do. That's why algorithms, the word algorithms is used when it talks about, computer science. And it comes from the word al-Khwarizmi. The other feature is algebra, comes from as Arabic to balance things. Al-Jabra means to balance things. And they worked out these X and Y's, which is algebra, in order to find the Qibla. So you can see that the world's advancement is based on the Qibla itself and what the Qibla relates to the Kaaba. And according to the sciences, you know, the Kaaba is the central part for what they call the golden ratio. If you relate to the center, the earth, the Kaaba's position on the earth. So whether people want to believe in Islam or not, it is basically proof that Islam is reality. Everything is based on Islam. And why did the mathematicians and the Muslims work out these particular features is to calculate the Qibla because they were travelers. They were traders, and trading is a core feature of life. Nabi Muhammad SAW was the last prophet, and he was an entrepreneur, he was a trader. So you can see Allah says the last prophet has got the major feature of the modern world, basically trading of all the world, but trading is the main feature. And then the Qibla is the central feature for all the calculations that people are doing today, and they don't want to give the Muslims scholars who study the Quran in order to develop these things. They don't want to give them the credit. They change their names into Christian names and European names. But you cannot run away from the word algebra and alchemy, which is chemistry, and physics itself, which comes from the Muslims. So there, and now I'm going to basically just deal with this particular sum, which is very interesting. They normally ask you, there's a block of 50 kilograms, which is the mass that's on a slanted surface, and the slanted surface has a frictional force, which is something that rubs against, of 0.3 friction coefficient. Now, these numbers are developed over years of experimentation with different materials, and they give it like a number, and they say, okay, this one is 0.3, the other one is 0.5, etc. The other one is naught, is no friction, because it's like ice or whatever the case may be. Then they make a list of these things. And so here you have this block on this slanted particular feature, and they say this slant makes a 30-degree angle. What I get 180 degrees, which is a straight line. It's a 30-degree angle. It's like there, more or less. 45 will be there, 90 will be there. And with the surface, okay? Then they ask you, draw the force diagram, okay, that acts on this particular block. In other words, what are the forces that allows this thing to actually stand still on that particular slanted surface? So now you have to remember in my previous video on the Allah owns the forces of the universe. If something is still, if something is still, then it means all the forces are in equilibrium. All the forces are acting on this particular feature in a way which is balancing the whole thing so that it actually stands still. So when they ask you for a force diagram, they ask you how many forces are actually acting on this block that allows it to stand still on this particular surface. So now you look at all the forces. You take the center of the block and you look at, there's a force downwards like that, and that will be gravity, right? That will be the gravitational force. That is the gravity pulling the block down to the earth. Then you have that particular force is acting on it, but then you also have a frictional force that acts on it this way. See that the arrow there? It's keeping it upwards, yeah? So like a tension, a frictional force. And you get another force which is more a tension force that keeps it, that wants to go down. It's like a kind of a force that pulls it down, and the other force that pulls it up is equal, so that it's standing still. And then you have a force of the block that's actually onto the box is onto the surface. That's one force there. And then you have the surface pushing up against the block. So here you have a force diagram drawn from the center. You see the friction force is upwards. The resultant or tension force is downwards there. The gravity is down there. The box onto the surface is this way. And the surface pushing against the box is upwards. And that everything is in equilibrium because the box is standing still. So now they ask you to calculate the forces, the size of the forces that are acting on this particular box. So now you just simplify, and now you try to find out what are the formulas that they worked out over all the years in physics. And they figured out that force is equal to the mass times the acceleration. In other words, how much it accelerates or moves at a certain space, at a certain distance over time. Now, but F is equal to ma, which is mass times acceleration, and so many meters per second or so many kilometers per hour, etc. That's A. But F is also equal to mg, because g is also a force meters per second that goes downwards. But that g, which is gravity, okay, is actually a constant, which is 9.8 meters per second. Now that they found out that if they put a feather and they put a stone in a tube where they all suck out all the air, it will fall at the same particular time and distance and time, and it'll arrive at the same time at the bottom of the tube. If they put the air in, then the feather will go like this in the air, and the stone will just go straight down because it's so heavy it breaks through the air. They suck the air out, you get both of them are actually falling at the same rate. So they found that a constant of 9.8 meters per second. So now if you want to work out, so now you can actually work out that force that's actually acting on this particular block, which is downward, there's a downward force on it. So you can say, okay, so F is equal to ma, but F is also equal to mg. So g is 9.8, so you take 50, which is the mass, 50 kilograms, times 9.8, put it in your calculator, you get 419 Newton. Newton is like the unit for force, which is something of 1 kilogram moving at 1 meter in 1 second. So in this case, it's like 419 mass, etc. It's moving at a particular rate in 1 second. So now you actually have this force here. That's got this force down here. Okay. So now you've calculated that force, that is the one force. So there's other forces. You must work out that force that's down there, and you must work out that force that's there, how these three basically act on it to keep that particular feature. And then you must work out this force here, and this force here is given to you, this force here, and that force there. So, okay, we've got this force down here now. Now, if you look at that particular drawing, you can actually see, you can take this particular triangle, you can take it out and draw it there. It's like taking it out and sticking it there. So you will have now you've got this line here, which is 490. It represents a force of 490 Newton. But now, in order to calculate with trigonometry, you need to have the angles. What are the angles? So they gave you this one as 30 degrees. Now, in geometry, the rule is if you have any triangle, the angles of the triangle will always add up to 180 degrees over the period of time they discovered. Any triangle, it will come up to 180 degrees. So if this one is 30 and that block means 90, you can actually work out what that one is. So it's 30 plus 90 will give you 120, 120 minus 180 will give you 60. So that one is 60. Now you figured out that one is 60. Now, if this one is 60, then the opposite angle is also 60. You see? Opposite angle is also 60 because when two straight lines cross each other, the opposite angles are equal. So now you got this one and you got that one because this is a 90 degree with a 90 degree with a surface. So that's 90, that's 60. Now you can work it out. 60 plus 90 is 150. So that will be also 30 degrees. So you see, without doing any calculation, you can just know then that if this one is 30, then that one is 30. So, okay, but we calculated it now that one is 30. Now let's transport that into this one here. So now you've got this angle, which is 60. Okay. You got that angle, which is 90. We got that angle, which is 30. So now you got this angle, which is 30. Now you can start using your trigonometry knowledge. Okay. So let's see now. Okay, so now we're going to, let me bring that closer here. Okay, fine, let's see, it's closer now. Okay, let's take it a little bit closer and we can always flip it up and down here. Okay, so let's see. Yes, that's a little bit more clear. So, okay, let's see. We've now taken that triangle and we've moved it to that side. You can always stop and rewind, etc. Okay, so now you can apply trigonometry. Okay, now these are what Al-Khwarizmi created. Okay, sine and cosine. It's like relationships between angles and sides. That is basically trigonometry. So the sine of theta, which is sine of an angle, is equal to the opposite over the hypotenuse. The hypotenuse is this particular slanted one, because those are the two that makes up the 90 degree angle, and this one on the side is like the hypotenuse, is like the slanted one. So sine of theta, you get sine of theta, which is a relationship, cos of theta, cosine of theta, and then tangent of theta. And each one have a relationship, and according to the angle, and you can figure out what the distance is on that. Now they also use to do the theodolite, which they look through, and they can work out when they want to peg the size of the building they're going to build, the height of the building. They use this trigonometry. So you see, the Muslims have calculated all of these things which the modern world can actually work with. Okay, so now let's see. So sine of theta is opposite over hypotenuse. Then you get cosine of theta, which is adjacent over hypotenuse. Now, according to us, if we have a 30 degree angle, we can see that if we say opposite over hypotenuse, we can get the sine theta relationship. If we say adjacent of theta over hypotenuse, then we have the cosine relationship. Now, if we look at we punch it in now. We're punching to get now. We know this particular hypotenuse. We know that what is the value of it is 490 Newton. We know that. Okay. So now let's do it a little bit further away so that we can see. Okay, so let's see. Okay. So now how we do it, we find out what is the sine, we're first going to do the sine of theta. We want to do what is this force? What is this force? This force is actually the opposite of this. So what is that force? So we're going to use now, that's the opposite over the hypotenuse. We know the hypotenuse. So it will be sine of theta. The sine of theta is opposite over hypotenuse. We know that one. So we're going to work out this one first. So now we're going to do that. We type in on the computer type in sine 30 equals, and they give us the answer as the sine of theta is 0.5. That is the relationship of the side if this angle is 30, 0.5. Okay. So we know that is 0.5, the sine of theta. So let's see if we can now put those in order to calculate what's the opposite side. So now, remember now, if we have a relationship with a number, whole number on this side and a fraction on this side, the best is to put this one over 1 and then cross multiply. Okay, to bring the fraction onto a linear equation. So now if you cross multiply, you'll get opposite times 1 will give you opposite. Times the sine times hypotenuse is times sine of 30 times hypotenuse. Now we know that the hypotenuse, which is this angle, this one here, the size is 490, so you can put it in, and we calculated that is 0.5. So if we add up, if we multiply these two, because two brackets mean to multiply, we find that it is 245, and that could be Newton. That will be the force, this force here is 245 Newton. So now we calculated that force, which is the opposite of this particular. So this force here, right, which is this way here, okay, that force there is 240. This force that's running here is 245 Newton. Now we want to, that's so we've got this force now, and we've got that force, and now we must work out this force, which is actually adjacent to 30 degrees. So now we have to use another relationship, which is cosine is equal to adjacent over hypotenuse. The cosine of theta, which is that theta is actually the size of the angle, is of 30 degrees is adjacent over hypotenuse. So now we type in on the calculator, cosine of 30 equals, cosine of 30 equals is 0.87. So we got that now. We've calculated x. Now let's see if we can now redo this particular side now. Okay, let's see now. So this is a whole number. We put it over 1 equal to adjacent over hypotenuse. We cross multiply. Adjacent is then times 1 stays adjacent is equal to cosine of 30 degrees times hypotenuse. So you calculated this here. So it's adjacent is equal to 8.7 times 490, and that is 426.3 Newton, which is now this force here that's running here, that's keeping this particular box, is 426.3 Newton. Now we've got all the forces. We've got the one that runs to that side, we've got the one that's running that way, and we've got the one that's running upwards. We've got these 3 forces. So now they ask you, what is the resultant force, which is this force here? What is this resultant force that keeps this particular box in equilibrium? Now you have to calculate the frictional force, okay? That frictional force. The force that's running opposite to the movement of that box that goes downwards. Now there's another formula. The formula for friction force, okay, is equal to the frictional coefficient, which they gave us. They say it's 0.3 times the force that acts against it. So what is the force that acts against it? If this is the frictional force that goes up, then the other force that's acting against it is the force downwards here. So it's 245. So you just punch in the information. It's 0.3 times 245.3, and you find it's 127.89 Newton. That's the frictional force that's keeping the box up. Now they ask you, what is the resultant force? So the resultant force is the force that goes down minus the force that goes up. And simply, there's the resultant force is 245, which is going down, minus 172.89, which is going up. And the resultant force, which is the difference between, is the actual 1 127.1. And there it shows you that these two are actually in equilibrium. In real terms, it's a little bit bigger because it has to keep it, the tension is keep the box up. Are you with me? It keeps the box up. But this one is slightly smaller, but it's basically 127 newtons, and it proves the point that the forces are in equilibrium. I hope this has done. If you go through this over and over, and you learn trigonometry, you learn your basic algebra, you learn your geometry, you learn your trigonometry, you learn your forces in equilibrium, which is in physics, etc., about frictional forces, and about the resultant force, etc. And now you have a very good understanding of what's happening in the universe and on the ground, etc., when you have these particular forces interacting on a mass. Now, these are all things that they have to calculate in order to work out how strong a pull must be or a push must be, like you have in the building trade or in the building of things, the cranes, how the cranes work, must balance that crane out so that it can pick up the stuff in the concrete, etc., from the floor. And how much force you need to keep that thing going. And, the cars and all of these things are being calculated like this. So it's a very fascinating piece of work, I think. And you can see how much the Muslims have contributed to modern science. And you can't erase it. They can't erase the Muslims' contribution and the centrality of the Kaaba, alhamdulillah. Wallahu ta'ala alam, I think it was. I hope it was good. I hope you see everything, yeah. And just zoom in and watch it over and over and redraw it. And I think you'll enjoy it because it doesn't matter how old you are. You can be young, 12, 13 years old, and you can do this. If you do it over and over, it's like driving a car. I started driving a car at 12 years old. You just have to do it over and over, and then it becomes automatic. So redo this, and you can see then that if you have any sum like this, you can actually go straight to this and say the opposite will be the sine of the angle times the hypotenuse. And the other force will be the cosine of the angle times the hypotenuse. And you don't have to go through all of this. So in another sum, you can just immediately use these particular formulas and calculate it. But this is a kind of a sum which we can teach people like from knowing absolutely nothing about physics and chemistry and trigonometry and algebra, knowing nothing. If you just understand the concepts and the numbers and the units, etc., now it becomes exciting. Inshallah, all the best. Assalamu alaikum.